Hey guys! So now we're going to factor trinomials with a leading coefficient that is not 1. Okay? Not 1. So the first thing that we want to do is we want to GCF if we can. This includes your numbers and variables. If you can't, it's totally fine, but that's what we're going to start with. So for example, on number 1, okay, so I'm looking here. I have an a squared, an a, and a 15. So I can't factor out an a. And then I have 2, 11, and 15. I can't factor that out either. Now, this is really similar to what we did to factor trinomials with a leading coefficient of 1. There's just one more step. So again, we're going to draw this cute little big X, and we're going to write some notes right here. So what we're going to have in the top part is what we're multiplying to. So again, we're keeping our same structure of our big X. But instead of just having the third term, it's the third term times the first term. So it's third times first. So that's what number goes right here. The third term times the first term. And then underneath, we're still adding to get to the second term, because we're going to replace the second term with 2 numbers and then factor by grouping, kind of like we did before. But with a leading coefficient of something other than 1, you actually have to write it out this time. So sorry about that. No shortcut this time. And we're looking for 2 numbers to replace our 11. Okay, so what we're going to do is we're going to start multiplying. 2 times 15 is 30, so we want to multiply times 30, and then we want to add to get to 11. So again, I'm just going to show you, even if you figured it out already, what 2 numbers we're supposed to have. Now we're going to do 30 divided by 2 is 15 and 2. That doesn't work. And then we're going to have 30 divided by 3 is 10 and 3. That doesn't make 11. And 30 divided by 4, that's not going to work. 30 divided by 5, oh, it's 5 and 6. And 5 and 6 make 11. So 5 and 6 are going to be our second term. So we're going to rewrite and replace 2a squared plus 5a plus 6a plus 15. Now we factor by grouping, and you have to factor by grouping this time, and we're going to take the GCF out. So we take out our a, and we have 2a plus 5, and then of the second term, we're going to take out a 3. Remember, we want these 2 parentheses to match 100%. We have 2a plus 5. They match. It's so lovely. We take out this answer, which is 2a plus 5, and we have a plus 3. So this is our answer for number 1. Okay, I'll be right back. Okay, sorry. Trying to do this on a Friday is kind of bananas. Okay, so let's do another example. Oh, let's look at number 5. I like that one. So if I'm looking at number 5, I see that there's an n cubed, an n squared, and an n. So I know for sure that one of my greatest common factors is definitely going to be an n. Now, I want to get the biggest number that goes into all 3 of these. And the reason is because if you don't now, you're going to have to do it later. And it's not nice. So we're going to try to look now. So this one's a little trickier, and you kind of just have to be more familiar with numbers, I guess, to make it a little bit easier. You can always make factor trees, so let's just do that together so you can see an easy way to do this. It takes a little bit more time, but remember, you don't have that many problems every night, so it's going to be okay. So you have 18, which breaks up. I'm just going to make factor tree, so 2 times 9 is 18, and then 3 times 3 is 9. Then we have 30, and 2 times 15 is 30, and then we have 3 and 5. And then we have 48. And 48 is 2 and 24. And then we've got 2 and 12. And then 3 and 4. So I want to find my greatest common factor for all 3 of these numbers. So I have a 2 in each of these factored out numbers, and I have a 3 in each of these factored out numbers, which means that 6 is going to be the greatest common factor for 18, 30, and 48. So that's an easy way to do this, and once you've done it enough, then you can kind of guess or see what the numbers are. You could have also kind of guessed and checked if you wanted to as well. But yeah, anyways, this is how you can do it and not get messed up. Because sometimes we forget to take out numbers. So, oh no, sorry. Struggles. 6n is going to come out. So 6 divided by 18 is 3, and then I have 2 n's left, which you always want to keep on the first term. You want your first term to be a letter squared. And then we have 5n, and then we have minus 8, and there is no n. Okay, so now this trinomial on the inside is what we want to use for our big X. So we're going to multiply our 3 times our negative 8 and get negative 24. So we want to multiply to negative 24, and we want to add to 5. Again, I'm going to do it the same way just so that you can get an idea of what I'm actually doing, and then you can take shortcuts whenever you want to. So negative 24 divided by 2 is 12, and 12 and 2 don't make 5. So we're going to keep going. Remember, we're trying to add and subtract them. That's why I say they don't make 5. 8 and 3, they make 5. My 5 is positive, so if I was going to subtract these numbers, then my 3 would have to be negative, which works because my negative on my 24, so my negative got multiplied there, so that actually works really great. So it's a positive 8 and a negative 3. All right, so we're going to rewrite. I know there's not a lot of room, and I'm really sorry. 3n squared, and it doesn't matter what order you write these in, so I'm just going to write minus 3n plus 8n minus 8. It'll work either way. Okay, so now we have 6n, and we're going to take out our greatest common factor, which is 3n. So I have an n and a minus 1 left. And then we're going to do the same thing here. I'm going to add to take out that 8 because I want to keep that minus sign inside of my parentheses so that they match 100%. And they do. Lovely. Okay, we dropped down our 6n. And now our greatest common factor between these two terms is n minus 1. And our leftovers is 3n plus 8. So this guy is now all factored. It looks so good. If I multiply these guys together and then multiply by 6n, we're going to get this at the very top. The whole thing, not just those. Okay, well, my circles. All right, let's see. Trying to think of another one that I'd like to do with you. On like 13 and 15, again, just kind of like factor out your GCFs there, and then that's fine. Oh, we can do number 9. That's a good one. Actually, no, 11 is great. Let's do number 11. Okay, on number 11, notice that I have an n cubed, an n squared, and an n. So we immediately want to take out an n. And then I have 9, 6, and 80. So I know 9 and 6 have some like terms, 3, and I'm not sure 80 does. So all I'm going to do to check is we're going to do 80 divided by 3. Did not work. Okay, great. So no like terms there with the actual numbers. So we can just take out an n. So we have 9n squared plus 6n minus 80. Okay, then we're going to big X it. Multiply your 9 and your negative 80, and that gives you negative 720. And that's what we're multiplying by. And then we're going to add to get 6. Okay, well, heavens. If this is negative, I know that I have at least one of these are going to be negative. So I'm looking for 2 answers that multiply to give me negative 720, and when I subtract them, they give me positive 6. So I'm just going to go down the list. Negative 720 divided by 2. Nope. Negative 720 divided by 3. Nope. Negative 720, oops, sorry. Negative 720 divided by 4. Nope. Negative 720 divided by 5. No. Negative 720 divided by 6. No. Negative 720 divided by 8. No. We're getting there though. Negative 720 divided by 9. Negative 720 divided by 10. Negative 720 divided by 11. Negative 720 divided by 12. Negative 720 divided by 13. Negative 720 divided by 14. Negative 720 divided by 15. Ooh, negative 720 divided by 16. Negative 720 divided by 17. Negative 720 divided by 18. Negative 7, oh heavens, 20 divided by 19, negative 720 divided by 20, negative 720. We're getting a lot closer. These things, this is a really big number, and if you noticed it wasn't working at the beginning, you can kind of skip numbers until you get to something that you think might be close, and then try those numbers around there. I always forget which numbers I did, that's why I try not to skip. But look at what we've got. We have 24 and negative 30. That will give me 6 for sure. So I am going to use, I'm not going to keep it a negative 30 though, because our 6 needs to be positive. So I want a positive 30 and a negative 24 will multiply to get me negative 720 and add to get me 6. So 9n squared plus 30n minus 24n minus 80. Okay, so now we take out our next GCF. And let's see, 3n. So then we have 3n plus 10 minus 8. 3n plus 10. Parentheses. So I put a big parentheses around my outsides. So then I have these cute little inside parentheses. So that's why they're double. Keep my n out in front. Then I have 3n plus 10 matches with 3n plus 10. And the leftovers, if I take 3n plus 10 out of this term, I'm left over with 3n. And if I take 3n plus 10 out of this term, I'm left over with minus 8. So this is your answer. Okay, if you have questions, please let me know. Hopefully that answered all of the questions that you had with factoring trinomials with the leading coefficient not being 1. Have a great day, guys. Bye.